That's, my name is Mr. Ehimari Andrew, this is Daily College. We want to look at it. The subject physics. And the area we want to treat is expansion of solid. Of course, it's not a new topic. We have dealt with this topic even before this little break came in. But we want to emphasize on the relationship between linear expansivity, area expansivity, and volume expansivity. We know that solids have length, breadth, and thickness. If the expansion of a solid is only along the length, that is called linear expansivity, alpha, as the symbol. But if it includes both the length and breadth of the object, then we talk about area expansivity, beta, as the symbol. But if we include the length, the breadth, and the thickness of the object, then we talk about volume expansivity of the solid, alpha, as symbol. But now we look at the definition. Already we know from the definition that linear expansivity mathematically linear expansivity is equal to change in length over original length times delta theta, that's change in temperature. Of course, we know that the L1 is the new length, L0 is the original length before the object was heated. The LO still repeated itself down. Then we have delta theta, which is change in temperature. So L1 is equal to new length L0 equal to original length then delta theta is equal to theta 2 minus, of course, let me call it theta 1 minus theta 0. Theta 1 means new temperature, but theta 0 means original temperature. Where theta 1 is equal to new temperature theta 0 is equal to original temperature. What I'm trying to say here is that if as a cook you want to boil water, immediately you pour the water inside the pot, you take your temperature, your thermometer, and read the temperature of the water at that time. So whatever you get before you start heating it, that temperature you obtain before heating the substance is called theta 0. If, for example, when you put your thermometer, it reads 10 degrees Celsius, show that your theta 0 is 10. Then after heating, maybe you heat up to 80, and when the water now becomes hot, you put thermometer and give you 80 degrees Celsius. That means your theta 1 becomes what? 80 degrees Celsius. So understand what I mean by that. Original simply means what it was before you start heating it. So understand the formula we use. So this is the formula for finding linear expansivity of a given object. Now we can now find the change in temperature because we are so concerned about the change in length. Let's make our change in length subject of formula. Let's make our change in length subject of what? Formula. So let us multiply. If we cross multiply here, we find that we are going to have L1 minus L0 equal to alpha plus, excuse me, alpha LO delta theta. Because when you cross multiply, you know, this one come and meet here, while this one come here. So L1 and L0 equal to this. So let's make our L1 such a formula. If we do that, our L1 is equal to, no, this one go to the front. So minus was minus LO before, by the time it goes, it become plus. So it become L1 delta theta plus L0. So this one have crossed to the other side. So we can collect the like terms of what we have here. So we can collect the like terms. So let's collect that. What is common here and here? If we check what is common here and here, find out LO is common here, LO is common here. So if it's common, we'll bring it to the, I want to go this way. So let's take it to the other side. And so we now have L1, which is new length, equal to LO, which is common. Because LO is common, what's the remaining side of the bracket? We're going to have what? Alpha delta theta plus 1. What we're going to have inside the bracket. But here we can also find, we have been told from simple experiment that alpha, that beta is equal to 2 alpha, and that gamma is equal to 3 alpha. Please take note of this. Which means area expansivity is the same thing as 2 times linear expansivity. Volume expansivity is equal to 3 times linear expansivity. If we get that from what, let's call this one equation 1. So we can derive equation 2 using what? Area expansivity. You know, now we are dealt with linear expansivity. We are using L. For area expansivity, instead of me using L1, we use A1. So for area expansivity, we now have A1. Let's compare with what we have here. So we have A1. So instead of using L0, we use A0 bracket. So using alpha, we now use beta. We now use what? Beta, because area I'm talking about beta. I've told you earlier before. So using beta alpha now, we now use what? Beta. Delta theta plus what? 1. That is this for area expansive. I call it equation 2. But from the analysis, A0 can be written as L0 B0 because area means length times breadth. Why am I using L and B? Because I can replace with area of a rectangle. Most time we are using rectangular face, and the area of the rectangle is length times breadth. So I'm using area. I can use length times breadth to represent it. Then also you know that beta, from what I'm giving you, beta can be written as well 2 or alpha. So let's replace it into this equation 2. Substitute into equation 2. Substitute into equation 2. If we do that, we're going to have what? A1 first equal to A0 bracket. So instead of me writing beta say when you get beta, use 2 alpha. So in this I'll write what? 2 alpha delta theta plus 1. So I can also again know quite well that A0 is same as what? L0 B0. I can also write A1 equal to S0 B0 bracket 2 alpha delta theta plus 1. And the last one, you can call this one equation 3. So the last one is using for gamma. So for gamma talk about volume expansivity. Gamma talk about volume or expansivity. Remember this one talk about area. Area expansivity talk about what? Area. Then volume expansivity. For volume expansivity, which is gamma, we have, looking at question 1, 2, so using L, and I'm going to use V because we're dealing with volume. I'm going to have V1. So I'm having L1, I'm going to have what? V0 bracket. So I'm going to use alpha, like remember we are using gamma now because we are in volume. I'll write gamma delta theta plus 1. So we are looking at, we are trying to repeat what we have in question 1, but doing the appropriate values. So now we can still replace something here. Know it quite well that VO is LO BO HO as times. You can put it times 1, 2. So VO means LO times BO times HO. Whereas gamma is equal as what? 3 alpha. So I'm going to replace that. That's the only thing I will replace. Now, so your V1 is equal to, so I'm writing V0 now, right? LO BO HO brackets. Then I will have alpha. Remember, gamma will be replaced what? 3 alpha. Then delta theta plus 1. That's all about it. You can call it equation 4. So that's what we try to relate. Now you can find there's a relationship between linear expansivity, area expansivity, and volume expansivity. I just want to bring one question. Let's solve one question with it and see what will come out of it. Example 1. Find the new length of a rod of length Find the new length of a rod of length 20 meter whose initial and final temperature on heating are 5 degrees Celsius 60 degrees Celsius. Take the linear expansivity of the metal to be 1.2 times 10 to the power 3. So we're going to solve this problem. I'm going to solve this problem. Per Kelvin. So we're going to solve this problem. So we're asked to find the new length. So I always advise you, before you start solving problems, you must write out the parameters. The question says find the new length. I know L is the new length, L1, question mark. Of a rod of length, which means the LO. Before they start hitting the rod was 20 meters. Whose initial and final temperature are 5 and 60, which means theta 0 is 5, while the new theta, which is equal to 60 degrees Celsius. And they gave us the linear expansivity, which is alpha, to be 1.2 times 10 to the power 3 per Kelvin. So let's write the equation down. Of course, the equation for new length says, you can see the equation 1. The equation says L1 equal to S0 brackets open alpha delta theta plus 1. So from what we have now, we can continue. We are looking for L1. Let's follow the equation. L1 equal to, what's your L0? L0 is 20, so I put it at 20. Bracket open. Our alpha is given to us as 1.2 times 10 to the power 3 times, you can see this and this times here, times change the temperature. Change simply means the highest one minus the lowest one. What is the highest one? 60. Who's the lowest one? 5. 60 minus 5 give what? 55. So we are having here 55 degrees Celsius plus 1. So we now have that L1 equal to 20 bracket open. But this give us, open this will give us 1200 times 55 plus 1. So we now have that 55 times 1200. Okay, I found out that this is minus 3. 1.2 times 10 to the power minus 3. Minus 3. So we are bringing it instead of multiplying. So you're having 1.2 over 1000 minus 3. So if you do that, you're going to have L1 equal to 20 bracket open. This one divided, you're going to have about 0.0012 times 55 plus 1. So we multiply it. What do you have? 12 times 55. 55 times 12. 2 times 5, 10, carry 1. 2 times 5, 10 plus 1, 11. 1 times 5 is 5. 1 times 5 is 5. You have it 0, 6, 6. So, of course, the decimal place you are having is 3. 1, 2, 3. So, we are having about 1, 2, 3, 4. 1, 2, 3, 4. 0. So, you are having L1 equal to 20 0.0660 plus 1. And then we have L1 equal to 20 bracket open 1.0660. So by the time 20 multiply what you have here, we're going to have L1 equal to, let me check it, 10 660 times 20. 0 times 2. So we're going to have 0, 0, 2 times 6 is 12, carry 1, 2 times 6 is 12 plus 1, 13, carry 1, 2 times 0 is 0, put the 1 down, 1 times 2 is what? 2. You remove the decimal place. How many decimal places we have? 1, 2, 3, 4. 1, 2, 3, 4. So your answer becomes 21.3200. So you have 21.3200. Otherwise, L1 equal to 1.32 to 2 decimal 2 decimal place. So that is the answer. So I just place 2 questions for you. Solve it at home and send it to my WhatsApp number. It's okay. So, set your answer to my WhatsApp number. So you can send your answers to my WhatsApp number 07039688246. For any further question, you can call this number 08141360167. Okay, Mr. Andrew. So I am expecting your answer as soon as possible. Good day.